So let's get started. So yeah, thanks everybody for joining today. So we want to try and cover a lot of ground today. So this is a the title was designed to be a little bit vague. So as I said in the main session, we're going to try and cover topics across safe and sustainable operations. So we want to go, I think we're going to start off talking a little bit about coronavirus operating measures and things that we're doing to keep our user community safe at this time. Then I think we'll go to biosafety level 2, biosafety level 3 operation, which I know is relevant to several of the people on the call. I'm hoping to finish off with a little bit of a discussion about environmental sustainability. But the panelist that I've invited to speak hasn't managed to join the Zoom call yet, so we'll see how that goes. So with that, I'd just like to introduce Bilal.
Yes, I'm Bilal Qureshi. I work at Oxford, University of Oxford, OPIC. Oxford Particle Imaging Center. We are also part of the Diamond facility, national facility, with 20% of our time for the biosafety level 3 experiments. If you submit a proposal there, you ultimately come to us. My background is more biophysics, X-ray and cryo-EM, not virology. So when we discuss later, I would also like to say some things, how important it is to have a team around you, which understands biosafety level, which understands viruses, pathogens. Yeah, thanks for inviting me, and I will contribute more once my turn arrives.
That's great, thank you. And I was particularly keen to have Bilal on the call today because of his extensive experience working with biosafety level 2 and level 3 specimens. I'd just like to introduce Laura as well, who's just joined the line. So Laura is not a badge-wearing cryo-EM person. However, at Leeds, she's one of the people who has really been pioneering some of the conversation around environmental sustainability. So we'll come back to that towards the end of the conversation. Great, so starting off coronavirus operation. I'd be really interested to hear the group's experiences around how you've been modifying the way that your facility works in order to keep both your staff and your users safe during coronavirus operation. And the kinds of things I think I'd be interested to hear approaches on are how are you dealing with sanitizing of microscopes of work areas, how are you adapting how your users interact with your staff, and do you have any feedback on how that's going? Although this isn't a session on training, I guess inevitably training when you can't necessarily do as much face-to-face might come into this. So I don't know if anybody wants to just kick us off with their experiences.
Yeah, so one thing I would say, we never went into a shutdown when the coronavirus situation happened, and we discussed shutting down at least one of the microscopes probably, but that also we did not. We've been following the advice from the government, from the university constantly. So initially, we are lucky that we have a system that restricts number of people accessing the center. So we restricted many people. Very few people who are really working on coronavirus relevant projects were allowed to work in the labs. Again, a great thing that was, we were lucky with this. We have trained many people in the past, and we have many independent users, super users, who can operate completely on their own. So that one person would come in with his project, load the grids, use the microscope, and do everything. That person would not require any other help, typically. Yeah, and we restrict the number of people in the rooms. Normally, you can imagine control rooms fully jam-packed with the people. You know, everyone is excited. Up to 8 people jump in and are excited about the results, but that wasn't happening. We restrict the number of people in the control room to just 2, one for cryos, one for glaciers. They're really far apart. And even then, if you feel not really that comfortable, you can leave the control room and go and work from the lab which hosts the microscope itself. So you can operate also from there. You will have just one person in the room. We have allowed our people, or we forced our people basically to use hand gloves when they are operating and touching the panels, control panels, keyboard, mouse, and a new person comes in with new hands of gloves and they wipe everything. So the first person come in wipes out, and the person who leaves also wipes out everything. Also, when you're using the phone in the room, you have to use the hand gloves. Later on, once things started to be relaxed a little more, we start using, allowing more people to come in. Training is the biggest problem. Everything else is operational. I mean, if there's now we have people who are not fully independent. So if they come to our lab and we have to load for them, and they would do screening themselves. So what happens is we discuss with them how many grid boxes they want to load, which grids exactly they should tell us without, yeah, everything has to be done through emails without really face-to-face contact. And then you go into the room, you load for this person, you load his samples, and then allow the person to screen himself or herself. And later on, you can again set up after discussing with the person, and that social distancing measures have to be taken care of, that you don't come really close to each other. If it's difficult, again, we follow government guidelines, less than 15 minutes. If you come close to each other, you want to pass by, you want to quickly show something that's unavoidable, then it has to be very, very short. And 15 minutes is also long. We don't do that actually 15 minutes. Training is only difficult aspect. We have started training people again. I would say these people were already being trained and they had some sessions already. I don't think that we have started training someone completely from the scratch, and that would be tough in my opinion.
Yeah.
Yeah.
So one of the things that so thank you. I think that's really interesting, and I'd certainly recognise several of the challenges that you described. I know one of the things that has been troubling me slightly recently is around putting safe working protocols into place for our REM facility. Is that inevitably facility staff are bearing more of the risk in terms of being in a situation where they might contract COVID-19. So putting in place, as you say, we're working to government and university guidelines. However, just because of the nature of the work, it means that we are asking facility staff to be on site more than, for example, their peers, well, not their peers, but more than somebody who's in a postdoc role, for example, would be necessarily doing if they were microscopy focused. And in addition, we're going to be asking them to put to wear appropriate PPE, but then be in the same room as somebody or in the same environment as somebody while they're delivering some kind of face-to-face training. I don't know if anybody has, because I know many of you manage teams of facility staff. I don't know whether anybody has any experience with managing that kind of risk, because to be honest, beyond doing all of the mitigation that we can, I don't really know how to get over that intrinsic inequality that the role requires people to be on site.
I don't think you can, I'm afraid. But one thing that we're sort of concerned about is, if a member of staff comes down with COVID and has to isolate at home, what we don't want to do is for that to sort of stop our operation, because that's going to be a complete disaster. So what's been underpinning our thoughts is to keep a record of the close contacts that people have, and if we can show that we haven't had people under 2 minutes, under 2 meters, for more than 10 minutes, say, that's a strong indication that we are reducing the risk, and therefore the other people in the environment don't have to self-isolate as a sort of as a precaution. So keeping written records of, if you're going to be within 2 meters of someone for more than 15 minutes, what we're asking people to do is to actually record this, and forcing people to record this tends to get people to move further away from each other, because they don't want to sort of have to
go through the paperwork trail.
Yeah. So that's our thoughts in Oxford. It's sort of trying to understand what we can do to prevent the whole closure of the system and it collapsing just on the basis of a single person.
So we have a space booking system in place where, exactly as you say, people have got to book into individual spaces. So if a positive case comes back, we can easily track back and write a report and say, right, this person was in the same room as that person. I must admit, my own personal feeling on this goes to, if you're training somebody and it's a 2-hour training workshop, doesn't matter what it is, if you're in a fairly confined space with that person for 2 hours, to me, it's one of those things. I think even if you are maintaining 2 meters, I still think there might be additional things that we want to do to control the risk. And it's around bringing in all of those additional factors, because I can completely understand why the guidance is focusing on the 2 meters, because I think you have to deliver clear guidance. But putting into account things like room ventilation, the size of the room, are the people going between high touch spaces, you know, is it I'm showing you how to do something, stepping back and you're stepping forward and touching the same surface? Is that a potential route? It's quite interesting to hear Bilal saying that you're using gloves, because at the moment, because almost everything we do is in single occupancy spaces, that's not something we're doing, and it's an interesting idea. Maybe we should be. Ed.
And you also have to think about, as you say, the ventilation. So in our offices and our labs, I think we have 10 volume changes an hour. So, you know, we're probably the safest place in Oxford to be, actually, you know, in terms of within a building. The air is clean, you know, so you've got to think about these, you know.
So I just wanted to talk about the gloves. When this all started and we came back to work in May, the safety department wasn't so keen, neither were we keen on gloves, because we saw how people put them on and touched all kinds of things and forgot to take them off, and gloves can be worse than hands because everyone's gotten used to washing their hands. One suggestion they had, which was very useful, which we do implement in all our microscope rooms, is nylon wrap on the keyboards, because those are hard to clean. And people can just stretch out some nylon wrap, put it on the keyboards, use it in their session, and throw out. Eyal, who's here in this chat room, didn't like the environmental unfriendliness of it and thought about buying those keyboard covers that you can wipe down. And then we have spray and wipes, alcohol wipes in every room. So people just wipe down before they start their session, wipe down the mouse, change the nylon wrap. And honestly, as we all know, transmission is not so much by touch. It's not a lot of evidence for that. So if you do all that and you're wearing your mask with a person 2 meters in the room and you have nice airflow, some people keep the microscope rooms open. If they're not doing high resolution microscopy, the biologists like to keep the microscope door open to keep the air going through. So that's how we've been doing it. We've kept, Israel has now been in full lockdown for 3 weeks, but we've kept our lab open and all users have been using the microscopes, and we are not seeing people getting sick in our unit. We haven't had a recorded occurrence of that.
And long may that last. Ed, you've got your hand up.
So we had a scare for a bit. So we have about a dozen staff members on site. One staff member was sick and was showing COVID-19 positive symptoms, but he was COVID-19 negative. But that took a week because of testing. And so due to contact tracing, we had to pull out 8 staff members. And so for 1 week, there were just 4 of us running only autoloader systems. So we have a lot of tiered systems of, if we have so much staff, this is our capacity, we can ramp up and ramp down. But we rather not have had to engage that. At the end of the day, he just had a little tickle, COVID-19 negative twice by tests, but that caused a severe interruption.
Yeah, and I guess it's how, have you changed any of the ways in which you operate to prevent any future disruption if you were to have a similar thing in?
We have now separated, we have certain areas that are staff only now, and we've increased that, and certain areas that staff can just rest. So that's the main thing, where they can have the private space. They don't have to worry, they can take off their masks. We are in lab space mainly, so there's a lot of air exchange, but it's just on your feet all the day, wearing mask all the time. It does get tiring. And then we don't want a situation where people get tired and they get sloppy. And so that's just giving them enough time and breaking.
No, I think that's a really crucial point, because yeah, if you're asking people to come to site all day, but saying we're not going to, so at Leeds, there's no microwaves, there's nowhere you can go and fill your bottled water up. and there's only very limited rest areas which are thankfully available now. But you're right, the impacts that has on your working day, you know, you feel like you need to pack. I feel like I go in with like a hold all of supplies by the time I've got, because especially if I'm making grids in a dehumidified room, you feel like you just need to be drinking pints of water. Anyway, Joanna.
Yeah, I was just going to share what we're doing to protect staff. So just to get into our building is you have to fill out a questionnaire to say that you and no one in your family has any COVID symptoms and you haven't traveled around or done certain things. We have temperature checking, and people like sanitizing their hands as they come in, and their equipment. So you have to sanitize your laptop and everything as you bring it in. But we're also sort of running a rotation system. So certain people are in the lab, and we are relying heavily on TeamViewer to actually run all the sessions remotely after people have loaded the microscopes. So that's how we're doing it. We've gone as far as purchasing some hand panels so that we can run them more effectively from home, because I don't know if anyone's had experience with the little on-screen hand panels. They're really awkward, not very fun. I'm trying to think. Oh, our biggest problem, I don't know if anyone has a good solution for this, is trying to keep grid production speed up, because we are finding now that we have sometimes gaps where we cannot fill the microscopes. So we have downtime because we just cannot make grids fast enough and people can't get enough access. So that's our biggest problem. If anyone has a good solution to that, it's just because the prep area, the limited number of people allowed in, just slows everything down. Shared with other things. So if people are doing that, we can't use the VitrBot.
So how about maintenance? Because we upgraded all our cameras to K3s because our Catan engineers are essential workers. And that was very useful. Also, we did workflow tests because we just kept ourselves honest. Can we reach resolution that we think we can reach on a test sample? So that's what we do to fill time.
To add to TeamViewer, we don't use TeamViewer because of viruses, but computer viruses. Okay, so we are working in a closed system, and it was Sharon's idea actually to use our phones for recording the session, so we can transmit it when we do service work to students or to users. We're also working on trying to build a streamer, a local streamer of video that could transmit the video directly to the clients, just one-way streaming. So that's to reduce the presence of users in the EM lab. Another thing is for tutorials, we are now recording ourselves, giving tutorials. It should work on the 120 kV machines. And in fact, we're going to start testing these tutorials or the efficiency of the tutorials soon, as we have new people registered to courses. But I don't think that we can do such tutorials for the cryosys, for the high-end machines. It's much too complicated. So we don't have a good solution for that.
And I guess that's an interesting point, that the ability to put into place remote working procedures will vary significantly site to site based on the willingness of your IT department to implement certain solutions.
Right.
Sharon?
Yeah, I've been very jealous watching all the 3DM emails and listening to all these people talking about how they are using TeamViewer and other things to work remotely. Our IT department just has nixed everything. And that's why we've got these stands for the cell phones to share with people, but that doesn't mean they can work remotely. They actually have to come in to work. And I find that very frustrating indeed. And as Eyal mentioned, we are planning to teach remotely on the lower KV, the beginners instruments, but one of the ways we've relieved the pressure is something we never used to allow before. We never allowed students to teach students, people from the same group to teach a young, more junior member of the group. We always said, no, students can't teach students, they all have to learn from us. And now we're saying, yep, you guys can teach each other, and then we'll do a checkout. And that has helped with the plungers, that's helped with, our one big problem is clipping. I know, Ed, that you guys do all the clipping for your users, but we don't do that. We don't have that big a staff. So the users clip themselves, and we still haven't figured out how we're going to teach clipping. Maybe we'll do the same thing, but that's the scariest least for us, the scariest part because of the autoloaders.
Yeah, I find, so we used to have very tight control. We used to clip all of our users' grids. I relinquished some of that control because it's important that we train our users when they go and work in other facilities. And we started training people on site to do that. We'd been doing it for about a year before the lockdown, fairly successfully. But that would involve a facility manager standing, or facility staff standing over your shoulder going, are you doing this correctly? Clearly can't be done now. So I've had to, and this is a big personal challenge for me, I've had to basically we've basically now said, here is a very, very detailed instructional video, give it a go. And then we will inspect your grids within an inch of their life. But without, and for users who there is maybe a history of challenge with grid handling, then we just still do it for them.
Do you have, is that detailed video for teaching clipping available?
Yes, so there is.
We were talking to ourselves just about that yesterday after the first session.
I'll send you the link, Nature Protocols paper.
Yes.
I'll send you that one, but we've got a now slightly edited one with a zoom in and a few different places based on user feedback. So I'd be happy to share that as well. But it's essentially the same as what we put online for the Nature Protocols. Yeah, and it goes. We touched on this in the main sessions yesterday. As a community, there is a lot of reinventing the wheel here, because actually lots of sites, there's local variations, there's lots of things that we all do essentially the same, and grid clipping is one of those. And if we can all avoid having to make a detailed video of the same thing, that will probably help, across the community. I guess, yeah, going back to Joanna's point around occupancy and filling microscope time, I know from our side, we've increased capacity in the EM facility. Although our grid prep room is single occupancy, people's working day has been extended, and we found that has been a major way people have I guess compensated for that. But we are definitely seeing a trend that, especially for groups who work with challenging proteins, their lab access is affecting the samples that even come down. Yeah, it is a challenge, and I think it will be different in different sites for different people. So just a show of hands, whose facility is able to work with biosafety level 2 specimens at the moment? Awesome, so that's the majority of people in the room. How about biosafety level 3? You guys are the same facility, so there's one hand. Awesome. So I really wanted to, certainly in the UK, there is only one facility which is able to work with biosafety level 3 specimens, and that's down in Oxford, the OPIC Imaging Centre. So I just wanted to invite Bilal to say a few words about that and some of the ways in which you handle biosafety level 2 and level 3 specimens.
Yeah, thank you very much. Yes, and John can also add something if I miss something. Yeah, the first thing I would like to start is, as I said earlier also, I'm a biophysicist. My background is X-ray and Cryo-EM, but not virology, not biosafety level. So we have a dedicated facility manager, Robin Parson, who takes care of the safety side. He's a facility manager of the OPIC. So it's great to have him. He pursues any project with the user, with the PI, with us, the EM staff, from start to the end. I think it starts even at a cell culture level, biochemistry level, but with him, people would produce specific risk assessments and SOPs specific to that pathogen, to that virus. So you really have to look at that particular virus and then come up with a protocol, how you would deactivate it, how you would decontaminate and clean up the instruments. So that was great really as an expertise to have in the house so that we can do it. So for example, if you would use Vercon or if you would use alcohol to wipe out the plastic parts that you have contaminated or you have used. And for the metal parts, I would say, yeah, typically we put them in the oven at 70 degrees. Typically, so far, I have seen whatever work we have done for 3 hours or so at 70 degrees that decontaminates the metal bits. Otherwise, they can rust. Vercon can cause rust, so that's something one should avoid. The other great thing that we have is the lab itself. It is, you can work at biosafety level 2 or at level 3. This is where our cryo sits. So if you bring the whole lab to biosafety level 3, very few people will have access to it. So it's restricted with a card access. Very, very few, only 11 people will get inside. That's very important, that other people should not go in the lab once you're doing that experiment. On the door of the lab, we also have a system of placing a small piece of paper, not that small, it's A4 actually. It tells you about the experiment that we're performing, green, yellow, or red. So biosafety level 1, 2, or 3. It tells you about the pathogen we're using and also about the risk assessment. So it gives you some information and is also an indication for people to walk away if they are, if they should not be in that room. We have in that particular room, it's a negative pressure room, of course. The whole lab is under negative pressure, so only air can get in and not out. And then you have air volume changes, which are 30 times an hour. So it's more than outside. Outside is also safe, as John said, 10 times, 10 volumes per hour. But in that lab is 30 air exchanges per hour. And it's filtered, and then it's brought back in the room. So it's HEPA filters. The microscope itself has HEPA filters, double HEPA filters on the cryos, only single ones on the glaciers. Other thing, which is R&D with thermo, is still work in progress, but very much there we are actually. So one idea, depending upon the pathogen, and it can be killed or inactivated maybe just by cryocycle after you have you've done your measurements. But maybe it's a more nasty virus. It's not easy to deactivate it. Then you can actually heat up the whole cryos at 60 degrees or even more at 80 degrees. But 60 is what's probably good for the bits, for the components, for a prolonged time. Let's say 2 days, 48 hours. That deactivates many of the samples. But that again, that has to be looked at for each of the sample that we will be putting in the microscope. We have done some experiments, few more, and then we should have the capacity ready. And again, when we are using the plunger, or when we are loading the samples in the loading station, or clipping the samples, yeah, that should be done for biosafety level 3 samples should be done in a safety cabinet. Even you can put the whole VitroBot or Leica plunger in a safety cabinet. That would be a good thing. So these are the kind of bits that we have in place in terms of instruments. So we have the people who have the expertise who tell us what to do. And then we have the systems where we restrict unwanted people to go in. And then we have our capacity with the specially designed rooms, our specially designed bits on the microscope itself. And then we also fumigate, of course. Once you are done with the experiment, the nanocap, the cassette, that stays after you're loaded, that stays in the safety cabinet, and once it's dry, you fumigate it with, we have found hydrogen peroxide not to be the best agent, but formaldehyde works much better for fumigation. So that's the protocol that you follow. And then it also requires you to wear hand gloves, and that's something which is very personal because I loaded the first sample, and the very first time I did, I had absolutely no feeling what I'm picking. Basically, when you have the forceps in your hand with the hand gloves, it takes time. It takes really time. People have to practice, get used to it, and then if you're doing it in a safety cabinet, that requires a lot of practice. It's not just something you can start doing from tomorrow. So that's a bit which will involve a lot of practice.
I mean, the point is, so you do these things very slowly and carefully, and you're not trying to get grids through as quickly as you can.
Yeah. So one of the interesting things that it would be interesting for me personally to have a discussion around is what you have a requirement to decontaminate and at what stage. So for example, and this applies to both biosafety level 2 and biosafety level 3 specimens. And the reason that I'm particularly interested in talking about this is at the moment we're happy to take biosafety level 2 specimens, but we essentially control the risk for that on a case-by-case basis. So the way in which we would treat a biosafety level 2 amyloid fibril is very different from the way we would treat a biosafety level 2 human airborne virus, for example. For us, once the specimen is vitrified, as long as it stays in a vitrified state, we make an assumption that it is going, that then it goes into the microscope, it comes back out again. And as long as there isn't a problem with vitrification, we make the assumption that there hasn't been contamination of the microscope at that phase. We would only say there's been contamination of the microscope if there was a devitrification event. Is that a common approach across other facilities?
Yeah, for us,
yes. So I was going to say the heating elements that we've got installed by Thermo Fisher for the cryos would only be used if we have a CL3 grid that hasn't come out of the microscope cryo, in a cryo state. That's the only time we would want to warm up the cryos like that.
Yeah, so I'm a bit confused, Rebecca. As you know, I called you privately a while back about this. And you said, well, as you just said now, but the point is that if it warms up and you don't have a heating element, because most of our microscopes don't, I'm not talking about biosafety level 3. My other question is why would the rest of us want to do biosafety level 3? Can't we just fix the samples and, make them biosafety level 1? But that's another question. Biosafety level 2, I still don't understand how we're supposed to handle those if the autoloader warms up, because our Thermo Fisher engineers basically weren't willing to commit to say, oh, we're happy to come in and handle even just biosafety level 2 if it warms up. And so we don't really know what to say about it. I still don't understand exactly how you're supposed to handle biosafety level 2 if the autoloader warms up, and who's handling that? And if you don't have a heater in your
yeah, well, and more to the point as well, there are many biosafety level 2 specimens which are not heat inactivated. So even having the heating elements is not necessarily a catch-all, and this is where you can look at more sophisticated solutions like HEPA filters on the air outlet, and then you would simply pump the column essentially and pump it and hope to pump the specimen out, probably through.
Is that what you do? Is that what you have?
So we don't have HEPA filters in the. So I should say, so we don't work with biosafety specimens very much. Across our 2 cryoses that have been in operation since 2016, we've had one unplanned devitrification event. So what we look to do is plan for that worst case scenario, because exactly as Sharon says, you have to plan for it, even if actually it is a fairly remote possibility. So for us, we don't work with what I would call particularly challenging biosafety level 2 specimens. So we don't actually work with I don't think we've worked with anything that actually represents a risk to human health, and that helps significantly in terms of the risk assessments.
Okay, but this is your call and your education, so it's not something I can tell. I can't tell the Thermo Fisher engineers, oh yeah, Right, so they have to basically trust you, and that's in the end what we have to say is they basically have to trust us that if we put in biosafety level 2 samples into our cryos, they're going to be the nice kind of biosafety level 2 because basically every lab in the Weizmann Institute is automatically, I mean there's a certain baseline, but every single one is BSL2. So in fact, by default, our cryos room is BSL2. Although we didn't do anything about it specifically. And indeed, the only time you're worried about it is if it thaws out. And I agree with you, it happens rarely. So I guess the default for us will continue to be only nice BSL2 samples.
So for us, if we did have something, basically we have HEPA filters on the air inlets, but also on the outlets. So if there was a planned devitrification event, we would say nobody can go into that room for however long is appropriate for that sample. We would then essentially pump out and let there be, pump out the column, warm up the microscope, pump out the room, use that approach, and then we would send somebody in. And the PPE or the decontamination measures that they might then use, if for example they're opening up the autoloader, would depend on what it was. So if it was a virus, we might say, right, well, you open up the autoloader and then we're going to get a handheld UV lamp and expose it for 30 minutes, an hour to deactivate. But this is why we don't have a blanket a policy for any BSL2 samples, because we feel it makes more sense to implement control measures based on the risk posed by that precise specimen. But you're right in that it's much more labour intense and difficult to communicate, especially to a non-biologist.
Yeah, I wanted to say something. I mean, we've also only have the nicer BSL2 samples so far. What we explored when we were discussing with Thermo and R&D part, we have not gone down that route, but it might be possible that you can bring in fumigation gas through the nitrogen vapor line into autoloader. I don't think nobody has gone that line and down that line. Nobody has followed it up. Even we did not. But it could be a possibility. Who knows if Thermo is willing to explore that with us or with somebody else, just as an idea that you can fumigate the autoloader. Yeah, it could be pursued.
I guess on the fumigation thing, I struggle to see how they will authorize this, because it's basically bringing a lot of carbon in your column. Contamination is probably going to be horrible after that, even with very long cryo cycles. But anyway, I'd be very curious to see what they say about this. I think I have a question, I guess, that Ed and Rebecca probably already heard in the last conference we were together, and that's how do you handle BSL-2 that are airborne, basically, or could be airborne contamination. At the moment, the nice BSL-2, well, they're nice, and we don't really, we basically treat them like BSL-1 pretty much, because they have no risk to human, and it's easy. Or they have a temporary host in between, before human, and that's okay. But the one that are, especially on some bacteria that are BSL-2, it can contaminate the user just by breathing them. And I think that's at the moment I have that issue, because one of the group leaders that the University of Melbourne just hired is only going to work on that kind of samples. We have no biosafety cabinet. We have a VitroBot and all the microscope you want. But at the moment, I'm not very keen on him having, coming down and using the VitroBot without a BSL-2 cabinet, or is it called in Australia, biosafety cabinet, I guess. And I don't know if any of you have experience on this, and I saw Gergram is also from Melbourne, and I've asked him the question, but basically in Australia, no one has that experience yet. Then I don't know, how do you handle the VitroBot with BSL-2 samples? How do you decontaminate the VitroBot? Especially the little entry hole where you put the pipette through, which is very, very easy to touch, and there's a latch coming in and out, and it's very easy to contaminate within this. And how do you handle that? And apart from that, would any of you have any idea how to handle such a sample, or will you just reject them? Which in my case is, I don't think I have the option.
I must admit, I think on our health and safety side, we would struggle to work with an airborne BSL-2 without a biosafety cabinet. But it is noticeable that health and safety varies institution to institution. Does anybody have any helpful ways they've been tackling this for ERIC?
Fixation is not an option, by the way, because they don't want to do it fixed.
You have to think about the risk, really. I mean, if you're dealing with 20 mLs of solution, that's a different level of risk from 5 microliters. So one has to do a sort of a proper risk assessment, I think, really. And
we did that risk assessment, and it's the risk is minimum, but it is still there. When you freeze 3 microliters, 4 microliters, and the aerosol form from this will stay within the VitroBot chamber anyway. But my main concern is not to contaminate directly with the primary aerosol, I guess. It's to contaminate later on another user, because the VitroBot has not been cleaned properly. And that's my main concern, because direct contamination is almost impossible with such small volume in a closed environment. But anyway, I guess the questions are open.
I'm thinking, actually, I can't see, I'm not aware of any literature resource that describes the different ways in which you can make common EM equipment like the VitroBot more suitable for BSL-2 samples. And some of these are really simple measures, like we have parafilm discs in between the foam pads and the filter paper, to which Ed and Joanna are nodding, because I know this is something that's quite common in many facilities, to stop the sample soaking through onto the pad, which is then very difficult to clean. I'm wondering whether there might be a community use for a short communication which describes some of these common measures across the community that might be quite well referred to.
I was just going to comment on the same thing using the plastic discs, and then like you have to wipe out your Vitruvot chamber quite thoroughly, because if it's anything like ours, it collects quite a lot of humidity inside, especially if you're running it for quite a while. And if I was using anything, you'd have to wipe it down with some sort of either ethanol or some other antiviral, whatever you're using, I think. For us, it's not, we don't use any, we're all BSL-1 level stuff, but we do use unknown compounds. So you don't know the toxicity of those. So that's what we were trying to protect against, any contamination with those. So we wipe down things quite thoroughly, and people have to wear gloves when they're doing the wiping down and making sure it's clean before the next user, like disposing of the little pads and replacing them with new ones, and making sure that the filter papers end up in the appropriate bins, not just anywhere. Not in just a normal bin, that sort of thing. So we're a little bit careful with that stuff.
When you find a way to make users put things in the right bins all of the time, let me know.
I know, I wish I had a magic solution. But luckily, they're quite aware of how because they're unknown toxicity, they could be really quite seriously bad. So they are quite careful.
Yeah. So just in the last sort of 5-10 minutes of this discussion session, I wanted us to switch tack slightly into something which we don't talk about very much as a community, and that's our environmental impacts and how we can work to make our facilities more sustainable. So at this point, I'd like to introduce Laura, who works in the University of Leeds' protein production facility. And she's, as I mentioned earlier, been pioneering on some of this work. And I just wanted her to say a few words about the kinds of things she's been doing in her lab to make a difference.
So part of my role at the university is officially, I am a research technician, but 0.5% of my time I am a staff sustainability architect, which basically means I get to research sustainability and share anything I come up with my lab and with the school and the faculty as a whole, and hope that it makes a difference. So labs compared to offices, they use about 3 to 10% more energy, and a typical research London institute spends about 15 million per year on energy. And you can make lots of small changes to kind of affect that. One of the things that uses the most energy is an ultra low temperature freezer. But actually, if you switch your freezer from -80 to -70, you can save around 25 to 30% of your energy consumption without having an effect on your samples, which is obviously great. And fume cupboards use the most energy. And obviously the main issue, I think anyway, personally, is plastic waste. Lab plastics accounted for about 2% of global plastic waste in 2014, yet researchers made up 0.1% of the total global population. So that just shows you there what effects they have. Now, in the protein production facility, I've made lots of small changes to try and have an impact on our plastic use mainly. So I've reduced our plastic use by around 4,000 pieces of plastic per year so far. And it's all been really small changes that haven't had a massive impact on the way that we do our work. So I switched to paper weighing boats instead of plastic ones. I use glass Petri dishes instead of plastic ones. We reuse tubes for storing antibiotics and things like that can be washed out and autoclaved. And we encourage all our users to use glass beakers instead of falcon tubes if they're making up small amounts of buffer and transferring small amounts of liquids instead. And so one of the main drawbacks, I think, at the moment is that to improve sustainability in all labs and across everything is that we need to stop allowing sustainability to be optional. So there are lots of ways that some other universities and labs are coming up with to try and make people include sustainability. And one of those is, so in America, let me see what it's called. I do have it written. They're bringing efficiency to research grants. So they're called better grants, and they are trying to reduce the cost of research through sustainability. So I think they offer sponsor funding at universities and research institutions if they come up with more efficient ways of working, which is great. in the UK, we have LEAF, which is the Laboratory Efficiency Assessment Framework, and this was developed by University College London, and all labs can take part in it, as far as I'm aware. It just has lots of different criteria which users can implement to improve waste streams and energy efficiency, etc. And a really key part of that is that it has a tool to quantify savings in both carbon output and in pounds, which obviously is what a lot of facility managers in particular need to take a look at. And it's sponsored by UKRN. So yeah, it's something that they're trying to spread across lots of the universities in the UK. So basically, yeah, that's what I've been doing. And if you've got anything that you do, then it'd be great to hear about it, because it's always good to share ideas.
Thanks, Laura. That is a shocking statistic that single-use plastic laboratories contributed 2%. I hadn't heard that, and yeah, that's, as you say, it's quite a stark statistic. And I guess as people who manage infrastructure, we are all actually in a good position to lead on some of these changes, which, as Laura said, might be small in places, but add up to a big difference. One of the other aspects in terms of sustainability that probably affects many of our facilities is around hosting user visits, so hosting people travelling to our facilities. I know this is, Simo, this is something we chatted about the other day. I didn't know if you'd wanted to come in quickly on that and international travel to access facilities.
Yes, I mean, this is a matter of discussion, especially in vision of the new imaging center. We are trying to set up our model of operations, and I mean, I think together with Wim and Felix, it was quite clear for us that if we push as much as possible, remote access will make us more efficient, will stress less the people working in the facility, and we could reduce to the bone the unnecessary traveling. On the other hand, of course, we do consider the experience of our visitors. It's great to come to EMBL or any other imaging facility to enlarge your network and to have, you know, hands-on experience, even if they might not be allowed to touch the microscope. So I think that the COVID situation might help us with our cause in shifting more and more towards remote access, and we just have to then focus on how to make this, you know, a comparable experience for our users, and so that they can take as much as they would if coming here. We are working on this. It's not, you know, some things are not trivial and some things are not allowed, because for example, we were thinking about this clipping training, right? You have someone to be over your shoulder. Well, you don't need to if you have a GoPro on your forehead, you know, that records what you are doing, and someone remotely can tell you, no, stop. But at EMBL is not allowed to use video recording, for example, of the work of the employees. So all those aspects that, yeah, you know, are hard to tackle, but I think they're worth exploring for all the aspects I've discussed about. And I think EMBL, especially with the new Director General, is moving more and more towards a green EMBL. So we are doing our best to reduce traveling in general and all our emissions. And yes, an imaging center that will host roughly 300 users a year will of course have a huge impact. And yeah, so this is something we are actively discussing, and we're trying to also implement all the safety measures that, of course, although EMBL is an entity on its own, we usually follow the German government rules. And yeah, we are now actively working on it, but not easy to respect all the law, internal and external.
Yeah. No, it's really interesting. It's so I must admit, you know, for me, and in terms of this facility, you know, my facility, thinking about sustainability from single-use plastics, thinking about our users' travel is quite a new thing on my radar. And, you know, massive thank you to Laura for, you know, raising the profile of this internally within our university. If I put this out to the crowd, is this something which we're starting to see more and more universities taking an interest in a way that we think might actually help us to implement some of these changes which might make a difference? Or are you like I was 6 months ago, where you're like, yeah, oh yeah, I forgot that recycling applies at work as well as at home, which is a dreadful thing to confess, but that's where I was.
I just had a quick question. If anyone, so I think we tend to be quite wasteful with our liquid nitrogen, and I'm sure that has a high energy cost because it gets delivered and also making it. Does anyone have a good feeling of, I have lots of people that are too paranoid to even use a little bit their excess nitrogen just to top up the sample storage due. I feel that this is okay and it's not going to cause a lot of grid contamination, and it's a good way to use some of that excess nitrogen, but trying to get people to agree. People have all different levels of paranoia. I don't know if there's any sort of consensus in the community about what's too contaminated, what will contaminate grids, what won't, that sort of thing.
If I can visibly see frost in it, I won't generally chuck it into a dewar, but you know, if it's been in our freezing room and it's had a lid on it, then I chuck it into the dewar all the time. And nobody ever complains. So Eric's laughing. Eric, do you want to come in?
Yeah, I think I'm pretty much the same. Even sometimes if there's contamination, I put it in. I mean, my school of thought is probably slightly different than most people. You can prepare grids with liquid nitrogen around the box that's horrible and full of ice. It's very unlikely that it's going to fall on you. And in my experience, you know, I don't say my grids are perfect, far from here, but the quality of the liquid nitrogen that surround the VitroBot container is almost irrelevant. I mean, you know, there's probably some extent where at some stage it's going to be bad, but I've prepared grid with liquid nitrogen just as an experiment, which was completely white with ice, and I had no more contamination in the form. I mean, you know, some people might have different issues, and I see some of my users are preparing grid in conditions that are horrible. The grids are either very good or very bad, but I think the issue is the transfer. It's not what happened in the nitrogen itself. Then you know, I have no problem chucking the leftover of nitrogen in the storage whatsoever.
Yeah. I agree. It's trying to get some of my more paranoid people to, also they want to fill the most ginormous container of nitrogen all the time. And we run out in the building sometimes and it's just like, you don't need all that. And then they don't want to use it. They just want to dump it all. So it's trying to get them to conserve that a little bit more. I'm going to make a big effort when I'm back from maternity leave.
So I just want to say thank you very much to Laura for coming in and talking to us around those environmental aspects. Like I say, I think it's certainly something which, for all of us, being in a facility management position, if it's on our radars and we can help our users work in a more environmentally sensitive way, then that's a great place for us to be. And I'm sorry that we only managed to dedicate the last little bit of the session to it because it's such an important topic, but I'm sure it's something that we'll be hearing more of in the months and years to come. Thank you very much to Bilal as well for his contributions in this session as well. Much appreciated, and thank you all for coming. I think it's been a good discussion.